Every year, millions of people suffer heart attacks. Many of them exercise regularly. Many of them eat healthy food. Many of them feel perfectly fine. Until the moment it happens. No warning. No obvious symptoms. Just a sudden collapse. Here's the unsettling truth. Your heart could be developing a life-threatening blockage right now. And you might feel absolutely nothing. No pain. No signal. No clue. Because the most dangerous heart attacks rarely begin with symptoms. They begin with something silent, something slowly growing inside the arteries that keep your heart alive. And by the time the body finally reacts, the damage may already be underway. So how does this happen? How can a heart that feels completely normal suddenly fail? To understand that, we need to look at what's quietly happening inside your arteries every single day. Your heart is an incredibly demanding organ. It beats roughly 100,000 times every single day. Every beat pushes blood through a vast network of vessels. If all of your blood vessels were placed end to end, they would stretch more than 60,000 miles. But when it comes to heart attacks, only a few of those vessels truly matter. They are called coronary arteries. These arteries wrap around the heart like the roots of a tree. Their job is simple: deliver oxygen, remove waste, keep the heart muscle alive. Without a steady supply of oxygen, heart muscle cells begin to die within minutes. And that is why coronary arteries are so critical. But over time, something begins to collect along the inner walls of these arteries. Tiny particles of cholesterol, inflammatory cells, fragments of fat and protein. Layer by layer, these materials begin to accumulate, slowly forming deposits known as plaque. At first, these deposits are extremely small, so small that they barely affect blood flow, which is why most people feel absolutely nothing during the early stages of heart disease. And this is what makes the condition so deceptive, because plaque can grow quietly for years, sometimes even decades. Most people imagine clogged arteries like a pipe filling with debris, a simple blockage that slowly reduces flow. But real arteries behave very differently. When plaque first begins forming, the artery wall often expands outward. Instead of narrowing immediately, the vessel stretches to create space. It's the biological equivalent of widening a road when traffic increases. Blood keeps flowing. Oxygen continues reaching the heart. Everything appears normal, which means plaque can grow silently while the body compensates. No pain, no symptoms, no warning. Your body is remarkably good at hiding the problem, until suddenly, it can't anymore. Here's something that surprises many people. The most dangerous plaque is often not the biggest blockage. In fact, many heart attacks occur in arteries that were only partially narrowed, because the real danger isn't size, it's instability. Imagine a blister forming beneath the inner surface of an artery. Inside that blister is a mixture of fats, immune cells, and inflammatory debris. For years it may remain stable, but if that thin surface suddenly tears open, everything changes. Your body reacts instantly. Platelets rush to the site. Clotting begins. Within seconds, a blood clot can start forming. And that clot can suddenly block the artery completely. Blood flow stops. Oxygen supply disappears. The heart muscle begins to suffocate. This moment is the beginning of a heart attack. But the story inside the artery doesn't end there. Long before a plaque ruptures, a quiet biological battle is already underway. Inside the artery wall, cholesterol particles are constantly moving in and out of the bloodstream. When LDL cholesterol slips beneath the surface of the artery lining, the immune system responds immediately. Specialized immune cells called macrophages move in to clean up the particles. At first, this process helps protect the artery. The macrophages absorb cholesterol and remove it from the vessel wall. But when cholesterol levels remain high for long periods of time, the system becomes overwhelmed. Macrophages begin absorbing more cholesterol than they can safely process. They swell with fatty material. Scientists call these swollen cells foam cells. Over time, millions of these foam cells accumulate beneath the artery wall. Together, they form the core of a plaque deposit. But the immune response doesn't stop there. These cells release inflammatory signals that attract even more immune cells. The environment inside the artery slowly becomes inflamed, and chronic inflammation weakens the protective layer covering the plaque. Think of it like rust slowly weakening the surface of metal. From the outside, everything may look intact, but internally the structure is becoming fragile. Eventually, the thin protective cap can rupture, and when that rupture occurs, the body treats it like an emergency wound. Platelets rush to seal the injury. Clotting begins immediately. In most parts of the body, this reaction protects us from bleeding. But inside a coronary artery, the same reaction can suddenly block blood flow. A clot that begins as a repair mechanism can rapidly grow large enough to obstruct the vessel. Within seconds, the artery may close completely. Blood flow stops, oxygen supply disappears, and the heart muscle begins to suffer damage. This entire sequence can happen incredibly fast, sometimes within minutes, which is why early recognition of symptoms is so critical. Many people hesitate when they feel something unusual. They assume the discomfort will pass. They try to rest or wait it out. But during a heart attack, waiting can be dangerous, because every minute without oxygen means more heart muscle is lost. Doctors often describe the heart as a pump made of living muscle. When part of that muscle dies, the pumping ability of the heart becomes weaker. In severe cases, this damage can lead to long-term heart failure. That is why modern cardiology focuses not only on treatment, but on early detection, identifying risk years before a blockage ever occurs, because preventing plaque buildup is far easier than repairing heart damage after the fact. And the earlier the process is slowed, the greater the chance of protecting the heart for decades to come. Now imagine a real situation. A man in his early 50s goes out for his usual morning run. He runs several times every week. His weight is normal. He doesn't smoke. He considers himself healthy. Halfway through the run, he notices something strange. Not sharp pain, just a deep pressure in his chest, almost like someone tightening a belt around his ribs. He slows down. Maybe it's dehydration, maybe stress, maybe he simply pushed too hard. So he keeps walking, but inside one of his coronary arteries, something dramatic has just happened. A plaque that had been quietly growing for years has ruptured. Platelets rush to the site. A clot begins forming. Blood flow begins dropping. Minute by minute, the heart muscle receives less oxygen. The man still doesn't fully understand what's happening. He only knows something feels wrong. And this is exactly how many heart attacks actually begin. Quietly, confusingly, without the dramatic warning people expect. Inside the heart muscle, cells depend entirely on oxygen to survive. Unlike many other tissues in the body, heart muscle cannot simply pause. It must keep contracting every second. Without interruption, when blood flow suddenly drops, these cells enter a state of crisis. Energy production begins collapsing. Acid starts building up inside the tissue. Electrical signals that coordinate heartbeats become unstable. If the blockage continues, heart cells begin to die. This process is known as myocardial infarction. In simple terms, it means part of the heart muscle is being permanently damaged, and the longer the artery remains blocked, the larger that damage becomes. This is why doctors often repeat a simple phrase: time is muscle. Every minute matters. Restoring blood flow quickly can mean the difference between a small injury and permanent heart damage. When someone arrives at the hospital with suspected heart attack symptoms, doctors move quickly. One of the first tests performed is an electrocardiogram. This test records the electrical signals of the heart. Certain patterns can reveal whether a coronary artery may be blocked. Doctors also measure proteins in the blood. When heart muscle cells are injured, they release specific markers into circulation. One of the most important markers is called troponin. Even small increases can signal damage. If a blocked artery is confirmed, the next priority is restoring blood flow. One common treatment is coronary angioplasty. During this procedure, a thin catheter is guided through a blood vessel toward the blocked artery. At the tip of the catheter is a tiny balloon. When the balloon inflates, it pushes the blockage aside and reopens the artery. Often doctors place a small metal mesh tube called a stent. The stent acts like a scaffold that keeps the artery open. When performed quickly enough, this procedure can restore circulation and sometimes save a life. But the real power lies in prevention, because plaque doesn't appear overnight. It develops slowly, often over decades. Several factors accelerate this process: high blood pressure, smoking, diabetes, chronic inflammation, elevated LDL cholesterol. These conditions damage the inner lining of arteries, making plaque formation far more likely. Over time, the risk compounds quietly, year after year. Modern medicine has also developed tools that help detect hidden heart disease earlier. One example is a coronary calcium scan. This scan detects tiny calcium deposits inside coronary arteries. Calcium is often a sign that plaque has been present for a long time. Higher calcium scores are associated with greater cardiovascular risk. Another imaging test called CT coronary angiography can visualize plaque directly inside the arteries. These technologies allow doctors to identify danger long before symptoms appear, which means prevention can begin earlier. Your heart beats roughly 100,000 times every single day. Every beat depends on arteries no wider than a drinking straw. Most of the time, they do their job silently, without complaint. But when those arteries begin to fail, the consequences can be sudden and severe, which is why understanding how heart attacks truly happen matters so much. Because the earlier we recognize the silent process inside our arteries, the more power we have to stop it before it ever becomes a medical emergency.